Here's a derivative problem that looks absolutely terrifying to me. It looks terrifying because it appears we have an inverse trig function that's kind of vomitous, and we have a quotient here, so maybe we're supposed to get out the quotient rule. I'm not sure. Even if we did bust out the quotient rule, this appears to be another composition, so I would need a chain rule. So I have an inverse trig with a quotient rule inside of that. Oh, and that would mean a chain rule here, right? Because it's an inverse trig and then a quotient rule inside of that. So isn't that horrible? It's just icky. We're not going to do it that way. What we are going to do is a very sneaky workaround. We are going to rewrite this function with no more inverse sign in it. So how did I think of this? I see the inverse sign and I start thinking I should draw triangles. As a math teacher, that's always been a thing. It usually bails me out of some tough situations. So you see this inverse sign and you're like, maybe there's a better way. So what's going to happen is we're going to label this triangle with what we know about this expression. So what I know is that this is supposed to represent O over H. It goes into arcsine and what you get is the angle. So in other words, this thing is theta. So sine of theta is x over radical 5 plus x squared, right? That's the reverse of that. Okay, using the Pythagorean theorem, you can figure out that the adjacent side here is radical 5. So here's the really cute thing. It turns out that the inverse sine of this mess is theta, right? I made up this letter theta and I said that's just going to be theta. But theta is also equal to arctan of x over radical 5, right? Aren't these cuter? They're much better, much easier. So what if I used arctan and then I only have x over radical 5 and then there's only one x left? I really feel like a winner. I feel like I got something good. All right, so f of x is equal to arctan of x over radical 5. That's awesome. I'm ready to do f prime. And so, here's how it goes. It's still a chain rule problem, The derivative of arctan is 1 over 1 plus the stuff squared, and then you have to multiply by the derivative of the stuff. And so the stuff is x over radical 5, so that just goes in that slot. And the derivative of that is 1 over radical 5, so that goes in that slot. So boom, the derivative is done. It's all over but for the simplification, and that's kind of a subjective matter, how much you want to simplify. Here's what I'm going to choose to do. I see this 1 over radical 5 here, and I think that's kind of gross, so I'm going to combine these two fractions. And so I have here radical 5, that went right meow, and then I have this business that I turned into just x squared over 5, so already I think it's cuter. And next what I'm going to do is I'm going to distribute the radical 5 over the denominator, and I get radical 5 plus x squared over radical 5 on bottom. And so I feel like this is definitely simplified and gold box worthy, but I don't know. If you swing that way, what you can do is you can multiply on top and bottom by radical 5, and it actually will make the compound fraction go away. So if that's what floats your boat, that's totally cool. If any of my students wrote either one of these, I would be really happy. So anyway, by knowing how to simplify and work with expressions involving inverse trig functions, you've just made your life a lot easier computing a derivative.